coordinates can be used to represent the location of a particular point on a plane. So unlike our rectangular coordinate plane, which plots a point using the coordinates in the form x, comma, y, polar coordinates are given in the form r, comma, theta. R represents the directed distance between the origin and the point. R is going to be known as our radius. Theta is the directed angle made by the initial side, which remember is the positive x-axis, and the line segment connecting the origin to the point. So we're going to start off very basic by just plotting some points since this is a little bit different. So here's your polar graph, and right away I'm sure it looks very different to you because there's all of these circles. Notice how I start at 0, and this one's counting in radians instead of in degrees, but it would be the same thing. This is then pi over 6, pi over 4, pi over 3, and so on. So those are going to be your angles. And they're all of our special angles, our reference angles in all of our different quadrants. And we can plot other points as well, but for today, since this is the intro lesson, these are the ones that we're going to be working with. These are all positive angles. However, remember that there are negative angles. I am rotating in a counterclockwise direction, which is why it's positive. But if I went in the clockwise direction, this would be negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, and so on. I'm not going to label them all, but if you wanted to, you could. Then notice that there are different circles. So for example, this circle has a radius of 2 because here's the first, here's the second. This circle has a radius of 3. So I'm going to plot the points that are given in a second, but I just want to start working backwards first. If I had the point here, this point here, this is on the second circle, so my radius is 2, and it's on the angle of 5 pi over 6. So this would be the point r comma theta. It would be 2 comma 5 pi over 6. So that's what we're going to be working with as we plot these points. So our first one, A, 2 comma pi over 4. So my radius is 2. My angle is pi over 4. So you should already be thinking pi over 4 is in quadrant 1. So here's pi over 4, this angle here, and I am going to this point. That's the point A. B is r equals 1, theta equals 5 pi over 6. 5 pi over 6 is in quadrant 2. So I find 5 pi over 6, and I want the first radius. That's the point B. C, r equals 4. My angle this time is negative pi over 2. So I'm rotating clockwise, which I don't have all of them labeled, but it is going to be down here, r equals 4 at negative pi over 2. This is the point C. The next one is r equals 3. Theta equals negative 2 pi over 3. So negative 2 pi over 3 is in the second quadrant. It's the same thing as positive 4 pi over 3. If you weren't sure about that, you could test by using your coterminal angles. Coterminal angles mean that I add 2 pi. But remember that adding 2 pi, in this case, is like adding 6 pi over 3. Which brings me to 4 pi over 3. So we did it correctly. And my radius was 3, so that's this point here. So we'll look at these more later on, but that point, 3 negative 2 pi over 3, is equivalent to this point. These are equivalent points. And you'll be able to find all equivalent points by finding coterminal angles and doing some other things as well. E. My radius is -1 and theta is pi. So our radius, remember, or R, is our directed distance. So while we typically think of it being a positive value, the directed distance tells me that I'm not going in the same direction that I'm used to. It's a reflection, essentially. Where is it a reflection over? Well, if you remember back to your coordinate plane, you can use your reflection rules. But here is pi. And if it was, this would be the point 1 comma pi, but it's not 1 comma pi. It's -1 comma pi. So it's over here. This is the point E, -1 comma pi, because it's a reflection. And then we'll do one more reflection. This has a radius of -2, and it has a theta value of pi over 3. So pi over 3 is in quadrant 1, and this would be the point 2 pi over 3, but that's not the point I was asked. Oh, sorry. This would be the point 2 pi over 3, but that's not the point I was asked to graph. I was asked to graph -2. So it's going to be over here. This is the point F, -2 comma pi over 3. So you would also be able to find the equivalent point for that as well if you wanted to.